In this lesson, you're going to learn about the second hashed type in Python, and that type is called a dictionary. Here's the general idea. So far, we have seen sequences which are indexed by non-negative integers. It might be interesting to have a type in which the indices can be more or less arbitrary objects instead of integers. Think of this. You want to have a phone listing, a phone directory. You might want to have a pairing between names and phone numbers. The names are strings. Phone numbers are numbers. And you want to have those, you want to associate names with phone numbers so you can easily look up a phone number. This is the idea behind a dictionary. First of all, let's go ahead and see how you create an empty dictionary. I'm going to say phone equals empty dictionary. Type of phone is class dict. Okay, so let's try adding some items to this dictionary. Or actually, let's go ahead and pre-populate it first. Let's try this on for size. To pre-populate a dictionary, you go curly brace, and then you say what the key is you want. 2746. All right. Okay, so here is and let's go ahead and put another entry in. So it's a comma-separated list of things that are separated by colons. Kind of reminds you of CSS, doesn't it? 2717. So now we have, I forgot my colon there. Now we have two items in this dictionary. So you might ask, well, how do I gain access to them? I can go like this. It's just like indexing, only you're indexing with a string. In this case, there we go. Okay, phone. We can go phone of Miller, and there's Miller's phone number. Now, how do you add something to the dictionary? Let's try that. I'm going to add something to the dictionary. Just use a key you haven't used before, like rash. All right, and then you can, so these accesses with the square bracket operator are actually L values. You can write to them, 2742. That's Flyboy's number. He's now in my dictionary. Let's talk about the in operator next. In, let's try 2742 in phone. Whoops. It appears that the in operator is not checking the list of values. If you want to check the list of values, you'd have to go like this. And it would say true. Let's see, maybe it's checking the keys. Let's try that on for size. Morrison in phone. Yes, I'm present. Labulio in phone. Oops, Labulio is not present. Now, it is an interesting fact that dictionaries, the dictionary keys must all be distinct. The dictionary's keys are in fact a set. And here's a reason why. If I go like this, if I say phone of rash is equal to 3742. What happens? If you assign for an existing key, the value for that key is simply overridden. Now, here's another thing that's kind of useful to see. The keys in a dictionary must be hashable, but the values don't have to be. Let's see. Let's give him 2 phone numbers just for fun. And I'm going to use a list because a list is not hashable. 2,700 and 4,482. I just pulled those numbers out of my hat. And you can see here that a dictionary holds, as it's slotted into a dictionary, it's sort of similar to a set. You create this big piece of memory and the hash function, and things are slotted in by their key, and the value just sort of hitchhikes along. Now, while we're in here, why don't we take a look at the documentation to see if there's anything of particular interest to us. Now, if you go to the Python built-in types and you hit Control F and type in mapping types, you'll come all the way down to this page. All right, and there's going to be lots of scary looking stuff here, but nothing terrible. If you cast a dictionary to a list, it'll return it will return a list of all the keys. The len function works. Oh, let's go ahead and demonstrate that. Let's compute the len of our dictionary of phone. And it tells you how many pairs are present. There are now 4 pairs present in the dictionary. It does not count the keys and the values. It just counts the number of keys in the dictionary. Okay, let's see what else is in here. You can see that D of square bracket key returns the item, and it is also an L value. You can write to it. You can check if it's in, if it's not in. You can clear the dictionary and remove everything from it. Okay, and let's see if there's anything. Oh, we can pop. If a key is in the dictionary, remove it and return its value. Otherwise, return some default value which you can specify. Let's go ahead and try pop, see what it does. We're gonna pop Roberts. So I'm gonna say out is equal to pop. Oh, is equal to phone dot pop. And I need to specify a key. Let's specify Roberts. And what gets returned is not the key. What gets returned is the value for that key. Because presumably if you popped it, you know the key already. You can, let's see, anything else I like in here? You can get the values out. We saw that. And I think we're pretty good in the documentation. There are, later on when we talk about loops, we'll be able to do things with dictionaries where we can walk through an entire dictionary. But that's part of the province of the next chapter. The next chapter is going to talk about boss statements. And so far in our programs, we can only write a program that's a list of statements and they execute in seriatim, i.e. one right after another. In the next chapter, what's going to happen is you're going to learn how to control the flow of execution of your program so that you can decide to skip code selectively or repeat it. So that will be items that are going to come up in the new chapter 1 area of this YouTube channel. So I will see you when I start that up.